Hello everyone, welcome back to our YouTube channel. In today's video, I am going to solve one problem that all element in two binary search tree. We have given two binary search tree. Remember binary search tree, not the binary tree. And we have to return a list of containing all integer from both the tree in sorted in ascending order. That means that we have given two binary tree. Binary tree means all if we have root, then all the element in the left side of the root is smaller than the root, and all the element on the right side of root is greater than the root. This is the property of the binary search tree. So we have given two binary tree. Here it is given that 2, 1, 3, that all the left side element is smaller than the root and all the right side element is greater than the root. And this condition holds for all binary tree, like that if this root is given, then it is a smaller than this one, then it may be the minus one, or it is greater than 1. It means that here 2 is given, so this is not formed. But that condition holds for all the root, that the left side element is always less than the root and right side element is always greater than the root. So in this question we have given two binary search tree, and we have to return a vector such that the element in the vector are in sorted order, element vector in the sorted order, and all the elements present from both the binary search tree. Let's try to understand this problem in the whiteboard. So, for example, we have given two binary search tree, let's 1 and 2. So, according to problem statement, we have to return a vector such that a vector include all the elements from both binary tree, like search tree, binary search tree 1 and binary search tree 2. So, what are the initial thought process behind solving this problem? So our initial thought process is that, what if we store all the element in the vector from this binary tree, and after that we store from this binary tree. We can store element in the vector from this binary tree using any traversal, like in order, post order, or pre-order. Okay, pre-order, and also store all the element of this binary tree into this vector using any traversal, like in order, post order, or pre-order. And after that sort this vector so that we get the sorted vector and return that vector. So it is a brute force approach to solving this problem. So the time complexity of that problem is n log n for sorting, and if there is n element in this uh, in this binary search tree, then takes traversal of big O of n, big O of n1, and traversal big O of n2, like that. So the overall time complexity of is n log n, and a space complexity is big O of n, because we store big O of n1 plus n2, because we store all the element from binary search tree 1 and binary search tree 2 from this vector in this vector, and after the sort. So this is overall time complexity and space complexity of this approach. So if you try to submit this approach, then we have gave TLE error. It means that time limit exceeded. So we have to optimize this problem. So how to optimize this problem? We should take benefit that it is given that it is a binary search tree, and we all know that binary search tree holds some property, like all the element to the left of the root is always less than the root, and all the element to the right of the root is always greater than the root element. So take the property of that. So this condition holds for all the roads. Suppose if we consider this route, then all the element to the left of this route is less than and all the element to this from the right side of this route is greater than. I think here I did something wrong. Here 3 is not happens, and so let's try to change that value. So I think here we take the 3. Okay, we take the 3, and here it is greater than, so takes the 4 value, because that condition holds for all the subtree, that a left side element is less and right side element is greater. So if we consider this road, then left side element is left and right side element is greater. So if I consider this, then all the element to the left side is smaller than this root, and all the elements to the right side is greater than this root. This root, I consider this root. If we also check this one, then all the element to the left side is less than, and all the element to the right side is greater. And I think I did a mistake here as well, because here we take, if we take here 11, then it's correct. Sorry for mistake. And here I take the 12. So all the element to the left is 10 and all the element towards the right is 12. It means that greater the 11. So this is two binary tree, binary search tree 1 and binary search tree 2. We also know that the in order traversal of binary search tree gives us what gives us increasing increasing order vector. Like that, if we do the in order traversal of this binary search tree, so what are the in order traversal? In order traversal is 2 3 4 5 6 7 8. This is an in order traversal of binary search tree 1. So this is an in order traversal. And as we notice that the in order traversal of binary search tree, any binary search tree gives the increasing order list. Okay, similarly, if we do the in order traversal of this binary search tree, then gives us 10, 11, 12, 15, 16, 18, and 19. This is a increasing order list. So one thing we can say that the in order traversal of binary search tree gives us increasing order list. Okay, increasing order list. So we take the advantage of that. So what I will do in this approach, that we know that the in order traversal of both the list are in increasing order. So first we do the in order traversal of both the binary search tree. Okay, and check check whether the first element of binary search tree 1 is less or second element in binary search tree less. Whoever element is less, pick that element in the uh, resultant vector and move forward. And what if the one vector is empty, then we take care of that cases as well. If something happens that one binary search traversal is empty, but the second binary search traversal is not empty, so in that cases, if this one is empty, then whatever the element rest is picked in the answer array. And if this binary search tree empty, then whatever element remaining in this binary search tree, pick that element in the answer vector to get that resultant answer. So see, here if I do the in order traversal of this binary search tree, then see what happens. Okay, here it is given the 19. Okay, so what I did, in order traversal, how happens, first start with the root node. Okay, root node, if the left of root exists, then go left, left of exist, go left. Then if left not exist, then then and also right, then pick that element and check whether right is exist or not. So pick that element, right is not exist, then move back, then again check the right is exist or not. If exist, then pick that element, then move in this way. In this way we do the in order traversal. Okay, if do the in order traversal. Okay, and same way we do the in order traversal of these things. So the in order traversal of both the binary, first binary tree start with 2 and the second binary tree is start with 10. So check whether here this binary search tree element is less than this binary search tree element. So first we push the 2 in the answer array, then move to that element, move to this element and compare with 10. So we have seen that this is 3 is less than, so again put 3 in the answer array, then move to 4 position, fourth, so this is lesser than, like that we did in the code. So now let's see how code we can write. So let's understand the coding section of this problem. So as I have discussed in the approach that we will do the in order traversal. We will do the in order traversal of the both the binary tree. Okay, and whatever the element we get a smaller, put it in the answer array. So let's understand the code. Here I take the answer array, that because the return type is vector, so we have to return some vectors, so take the answer array. Then after that take two stacks of type tree node s1 s2, because as we all know, if we wanted to do the in order iterative in order traversal, then a stack data structure should be required. Okay, so see, whenever one condition satisfy, right, like root 1 is not null, root 2 is not null, or s1 is not empty, then move inside the while loop and do the in order traversal of in first binary search tree. So while root 1 is not null, push it in the vector and move left. It means that move left and move left, and same thing for second binary search tree as well. Okay, and after that we check condition. If s1 dot top value is less than s2 dot top, it means that as if they check this one with this one, if this one is less, s1, this one is not less, so we move to the else part. So they put the top element from the second stack, put the top element from the second stack. Okay, put the top initially put the stack 2 element, then 1, again the left is empty, so nothing, 0 1. So compare this one, sorry 1 0 1 0, compare this one with this one, so this one is less. So we move into this part, then pop that element, and after that push it in the answer array. Take a answer array, push 0 in the answer array, and move root left part, right part. So right of this is not exist. So same thing happens till the all four condition not satisfied. So I hope you all understand this solution. So let's try to submit this solution in the Leetcode, and let's see what happens. So let's